name is Luis Andre Eldeneta from Grade 12 Aquarius. Units are a fundamental aspect of measuring physical quantities. They provide a standardized way to express and compare different magnitudes of a particular quantity. Units allow us to communicate and quantify various phenomena across scientific disciplines. Without units, it would be difficult to establish a common understanding and make accurate measurements. Physical quantities are properties of objects or phenomena that can be measured and expressed in numerical terms. Examples of physical quantities include length, mass, time, temperature, and electric current. These quantities are often categorized into fundamental and derived quantities, where fundamental quantities cannot be defined in terms of other quantities, while derived quantities are obtained from combinations of fundamental quantities. Units of measurement are specific standards used to quantify and express physical quantities. They provide a reference point against which measurements can be made, for instance, such as meters for length, kilograms for mass, seconds for time, and so on. Units enable meaningful comparisons and calculations in scientific and everyday contexts. Measurement error, refers to the discrepancy between the measured value of a quantity and its true value. It arises from various sources, including the limitations and instruments, human factors, environmental conditions, and inherent variability in the quantity being measured. Measurement error can be random or systematic, and it is essential to consider its impact when interpreting experimental data or making scientific conclusions. In the bottom, vectors are mathematical entities used to represent quantities that possess both magnitude and direction. They are essential in physics, particularly in describing motion, forces, and other physical phenomena. Vectors are represented by arrows, where the length represents the magnitude and the direction indicates the orientation. Common examples of vector quantities include as displacement, velocity, acceleration, and force. Kinematics is the branch of physics that deals with the description of motion, focusing on the concepts and displacement, velocity, and acceleration without considering the underlying causes of motion. It provides a framework for analyzing and predicting the behavior of objects in motion using mathematical equations and graphs. Kinematics is crucial for understanding the basic principles of motion in physics. In here, motion along a straight line refers to the movement of an object in a single dimension, typically represented by a one-dimensional coordinate system. It involves changes in position, velocity, and acceleration along with a line without any deviation from a straight path. Examples of motion along a straight line include an object moving back and forth on a truck or a car driving along a straight road. In the bottom, motion in 2D or two-dimensional involves the movement of objects in two more than one direction. In two motion, objects move in a plane and their positions are described using two perpendicular axes. In here on the right side, projectile motion describes the trajectory followed by an object that is launched into the air, and it is subject to force of gravity and air resistance if present. The path of projectile is parabolic curve consisting of two perpendicular components, horizontal motion at a consistency velocity and vertical motion influenced by gravity. Projectile motion is encountered in various scenarios such as a ball thrown or projectile launch from a cannon. There are three types of Newton's law, which was the first here in the top. Newton's first law, or the law of inertia. A law of inertia, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same velocity unless acted upon by external force. In here from the bottom, the second law, law of acceleration. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. And lastly, the third motion, the third of action and reaction. For every action, there is an equal and opposite reaction. When one object exerts a force and another, the second object exerts an equal opposite force when force on the first. The work and energy is a measure of applied to move an object through a distance. It is defined as the product of the force applied and the displacement in the direction of the force. Energy, on the other hand, is the ability to do work to cause a change. Work and energy are interconnected concepts, where work done as an object can change its energy state, such as kinetic or potential energy. Fluid mechanics is the branch of physics that studies the behavior of fluids, liquids, and gas at rest is in motion. It encompasses the fluid principles of fluid statics dealing with the fluid at rest, and fluid dynamics dealing with fluids in motion. Fluid mechanics plays a crucial role in understanding phenomena like fluid flow, fluid pressure, buoyancy, and aerodynamics. It has application in engineering, weather forecasting, and many other fields. Pressure per unit on the surface is a fundamental concept, and fluid mechanics plays a significant role in understanding the behavior of fluids. Pressure is calculated by dividing the force acting on the surface by the area over which the force is distributed. Thus, a unit of pressure is a Pascal. Pressure has diverse applications from studying the properties of gases and liquid engineering, designs of hydraulic systems, and atmospheric science. That's for Physics 1. Now we're back on season and Physics 2. Coulomb's law mathematically expresses the fundamental principles of electrostatics and provides a quantitative understanding of how electric charges interact. Electric potential is an important concept in understanding the flow of electric charge, circuits, and the behavior of electric fields. Capacitance is a property of a system, the conductors and insulators that determines its ability to store electrical storm in the form of electric charge. Understanding these concepts, including electric charge, Coulomb's law, electric field, electric potential, and capacitance, is essential for comprehending the behavior of electrical systems, electromagnetic phenomena, and the functions of various electrical devices. So that's all that I've learned on Physics 1 and 2. And also, I want to share, I most enjoyed on the lesson. I chose the capacitance lesson in Physics 2 on our last lesson because it was very interesting and also easy to understand. Although, since the school year is over, our topic in physics is wala siya naabot sa exciting part, but also we learned a lot. Thanks for Sir Hill Miradores for teaching us about the concept of Physics 1 and 2. It is very useful for our college life, our upcoming college life, also for our engineering classmates, also mine as a medtech or a nurse. Capacitance, parallel series are very interesting. It's easy. It's fun to learn. While though the Physics 1 is so complicated because I didn't understand that much, because